Hello everyone, welcome to this new format for Calc 2. Hope all of you are doing okay and you're staying safe wherever you may be. So this is our first video for this class. There may be a few things that maybe don't work out so well. If you have any issues, please let me know as soon as you can, and hopefully this week we can work out some of these issues. Alright, so today I want to start talking about Chapter 2. Chapter 2 is about infinite sequences and series. So today we're going to just start by talking about infinite sequences. Alright, so to talk about an infinite sequence, we talk about the idea of this, and we can look basically at what these words mean in the dictionary. So if we look at the word infinite, we see things like something immeasurably great, or unbounded, or unlimited. And if we look at the word for sequence, you can read through those definitions there. Probably my favorite is the second one, this idea of we have a list of things. And so from this, you can kind of get the idea that an infinite sequence is an infinite list of numbers. Now, what we mean by an infinite list, it means there is a first element, and a second element, and a third element, and a fourth element, and so on. And so we have a 10th element, a 100th element, a 27 millionth element. You can just keep going. All right, so if we look at the formal definition of a sequence, we see that we can define a sequence as a function which takes positive integers to some real numbers. The notation that we use for a sequence is this a of n, this a subscript n, where n goes from 1 to infinity. So for each n from 1, 2, 3, up to really infinity, we have a different number that we can denote by a of n. And so those are the individual terms of our sequence, are a of n. So the first term is a1, second term is a2, the 8th term is a of 8, and the 100th term is a of 100. All right, so now I want to talk a little bit about three ways that we can commonly define infinite sequences. So the first one, probably the most straightforward, is by using a formula. So for this one here, the example that I have is if we have the sequence defined by a sub n equals n over n plus 1. So here you can see that a of 1 equals 1 over 2, or 1/2. A of 2, you're going to get 2/3. And if you want to look at, say, a of 10 is 10 over 11. And when we use a formula, basically if you ask for any number n, what is the nth term of that sequence, we can figure that right away by just plugging n into our formula. All right, the second way that we can describe a sequence is very similar to the first. It's a description of the nth term, but we don't necessarily have a formula here. So the example that we have here is a of n is the nth decimal place in pi. So if we look at this, the first term of the sequence is 1 because the first decimal place is 1. So a of 1 is 1. The second term, a of 2, is 4, because the second decimal place is 4, and so on. And you can do that. The 100th decimal place of pi is given by a of 100. All right, the third way that we can describe a sequence is by a recursive formula. For this one, what we want to think about is that we have each term is described by terms that came before it. So this example here we see is f of 1 is 1 and f of 2 is 1. So we know what the first two terms are. And then for all other n, we see that f of n is n minus 1 plus f of n minus 2. And so looking at this, I mean, we get the third term by adding up the two terms that come before it. So the third term is 1 plus 1, which is 2. The fourth term, if we add up the two terms that come before it, the second and third term, we get 1 plus 2 is 3. And the fifth term we can get by adding up the third and fourth term. And so there we see 2 plus 3 is 5. And the sixth term, you can see if you want to add up the two that come before it, we got 3 plus 5 is 8. And so if we do that, you can sort of keep going. At every step, you can always figure out the next one, the next number there, and this can keep going on forever. All right, so I want to talk about the limit of a sequence here. All right, so when we talk about the limit of a sequence, you can see the notation that we use here. A sequence has a limit L. The way we use the notation for this is the limit as n goes to infinity of a of n equals L, or just a of n approaches L. And so here L is a number. It has to be some finite number. And the sequence has a limit of L if we can make the terms a of n as close to L as possible by taking n sufficiently large. And here we can talk about the idea of a convergent sequence versus a divergent sequence. The idea of a convergent sequence is that if the limit exists, so if it approaches some number L, then it is convergent. If as n goes to infinity, the sequence does not approach a number L, the sequence diverges. And I should say that if as n goes to infinity, the terms also go to infinity, this means that the sequence does actually diverge also.